Hello guys, we finalized the completed square and we are going to go through some practice questions. So first of all, we started from just normal quadratic expression and we simply need to use a complete square and convert expanded form into complete square form. So for example, the first one that we have is the following. So we need to, from x squared plus 7x plus 6, arrive to complete square. Alright, in this case I'll use method 1, just using the formula a plus b squared, which is equal a squared plus 2ab plus b squared, and I'll try to arrange this part into complete square. Alright, so that's expression. Yeah, let's see what we have. So according to the formula, we need to have x squared, then 2ab, so 2x instead of b, we are looking for what to multiply by in order to arrive to 7x. So obviously, first of all, I need to have 2 in the bottom part in order to cancel, and 7 on top in order to get to 7x. So that's why my b is 7 over 2. So I add 7 over 2 squared, which is 49 over 4. And I immediately subtract 49 over 4 and add the last term plus 6. Now we have expression in the brackets is the complete square. So complete square. So that's why our expression would look like as x plus 7 over 2, everything squared. And here I just managed myself to simplify. So negative 49 and 4 times 6 is 24, positive. So I'll get negative 25 over 4. Alright? If you need to factorize this expression, of course, never use complete square because it works really hard unless you're clearly asked to do that through it. Let's assume in some weird questions you asked to factorize through the complete square. Alright, so we have complete square for this expression is that one. And simply now, in order to factorize this expression, what we can do, we can say that this is another formula, which is a squared minus b squared. And in factorized way, you can write as a minus b, a plus b. Alright, so we'll get the following. 25 over 4 is simply 5 over 2 squared. And now we have the same pattern as here. So we just simply need to say that x plus 7 over 2 minus b, so minus 5 over 2, and multiply by x plus 7 over 2 and plus b, which is 5 over 2. Okay? If this expression is equal to 0, you can even solve that. But one more time, attention. Never use complete square in order to factorize. So for example, in order to factorize, you can use the fast way, either rearranging the middle term. Let's say, I can show you quick. So there are two ways actually: rearrange 7x into x and 6x, for example, and then combine with rest terms that you have. So I group x squared and x and 6x and x, so I'll factorize x here, and I also factorize 6 from the second group, and which left me with x plus 1 also, and then I factorize x plus 1 because this is common. And you see how fast, so x plus 1 is factorized, and here I'll get x plus 6 also. So you might be asked, like, why we have this so like weird instead of like normally what we have here. Because simply what you're gonna do, you need to add 7 over 2 and 5 over 2 and also subtract. So let's see how we can simplify so that you won't have any doubts that they're not the same. So if we simplify, 7 over 2 minus 5 over 2 is 2 over 2, or just simply 1. That's how we get the first factor. And 7 over 2 plus 5 over 2 is 12 over 2, which is 6, so x plus 6. And now you see they're identical. But never apply complete square in order to factorize. Okay, so that's how you can use complete square and how you can convert into complete square form if you are asked to do so. All right, so let's try the second question. In this case, I'll intentionally use a bit different form. So for example, you need to use complete square for the following: 4x minus x squared minus 3. All right, so pay attention how it's written. It's written not in proper order because normally you need to arrange in decreasing order of your terms. So that's why the first term is going to be x squared. So we just rearrange. We put it on the first place, this on the second place, and this on the third. So we'll get negative x squared plus 4x and then minus 3. Now we have a proper arrangement. However, I do one more step. I factorize minus 1, and here I'll have x squared minus 4x and plus 3. I just swap the signs. All right, what we're gonna do right now, we just need to use complete square in order to convert this form into complete square form. So that's why I separately put x squared minus 4x and plus 3 as in the pattern, and right now I'm gonna use the second approach, so using the formula. So I'll use because I see that this is a minus. However, I just use what we're practicing. I just use plus m squared and finally plus n in the end. Okay, now what I'm gonna do, I need to expand that. So expand, and I'll get x squared plus 2mx plus m squared and plus n. And now what I'm gonna do, I'm just try to compare with what I have here and here. So I set up the first equation. 2m should be negative 4, and m squared plus n is 3. So I write m squared plus n should be equal to 3. And now I just need to solve. So first I'm finding negative 4 over 2, which is m, so it's negative 2. And then I look for n, and it's simply 3 minus m squared, or 3 minus 4, you'll get negative 1. So hence I found all the values for m and n, and now I can rewrite as the following: x minus 2 squared and minus 1 in the end. So you can even check yourself. If you expand, you need to go back to your original expression. All right, however, before I had a minus, remember, and I convert this internal expression in the brackets into complete square form, so it's here. So simply, finally, I can write as minus x minus 2 squared, and minus 1 will give me plus 1. Okay, so that's how we complete square according to that. Okay, and the last but not least, I'll try to show you application to the vertex form for the parabola. So here, just try to write the vertex form for the following function. So of course I'll use quadratic function. So y from x, let's say, equals to x squared plus 3x plus 2, for example. And now I need to turn this expression or this equation into the vertex form. All right, so remember, vertex form is vertex as the minimum maximum point on your parabola, and it has coordinates h as x coordinates and k as y coordinates. So the general pattern that I'm going to use is yx equals x minus h squared plus k. Okay, so this is a bit different from what we use here, but no matter whether you use m plus m or negative m. So in this case, I will use negative h, and I'll do the same using the second method. I'll just simply need to expand x minus h squared. I'll use the second method again. So I'll expand it, and then I just compare it with what I have originally. So I have x squared plus 3x plus 2. And what I'm going to do, I just need to compare coefficient 3 is negative 2h. So from where h is simply negative 3 over 2. So you can use it, mentally. And 2 is k and h squared together. So this is what is known 2. So, and h squared plus k, I can write that h squared plus k is simply 2, from where I can find k. So k is simply 2 minus h squared, so 2 minus, and negative 3 over 2 squared will be 9 over 4 positive. However, minus because of the transfer into the right side. So that's why I'll get negative 1 over, negative 1 over 4. Alright, so I've got both k and h. And from where I can find the following. So y from x, actually in complete square form, or in the vertex form, will have the following structure. So x minus h means h is negative 3 over 2, minus and minus will give me plus, so plus 3 over 2 squared, and plus k. And k is negative, so negative 1 over 4. So hence I found the vertex, and I wrote in the vertex form my equation for the quadratic function. So vertex will have h and k coordinates, so vertex is negative 3 over 2 and negative 1 over 4. Alright, so, and the last what I'm going to do, I just want to sketch it. So y from x in factorized form will be x plus 1 and x plus 2, and that allows me to find simply x-intercept. So this is yx, and I can find easily negative 1 and negative 2. So negative 2 and negative 1. That points of intercept, this parabola goes upward because of the leading coefficient to be positive, it's 1. So that's why our parabola should go something like this. And this point will be 2 as y-intercept, okay? And the vertex. So I just put the vertex here. So as we're supposed to be, the vertex should be in half between negative 2 and negative 1, so negative 3 over 2. And y vertex is negative 1 over 4, as we found recently, negative 1 over 4. So that's in full correspondence with what we did. So you see, you can apply complete square to the vertex form in order to write your function in the vertex form, and also you can use factorizing in order to probably build your graph or sketch your graph very fast. So that's how it works, guys. So hope you took into account all those methods that I showed you. So be practicing, maybe just set up several more questions for practicing, but so my purpose was to demonstrate how this method can be applied to different problems. So hope you enjoy, guys. Don't forget to subscribe and share this video to anyone who's interested or struggling with. So that will be, for sharing, you'll definitely have some more benefits, and many thanks for other people who are really in need. So don't forget to subscribe if you'll be in touch with me and with the latest updates. So, you Daniel Dallas. See you guys.